Welcome to ACE Online and ACE Engineering Academy. I am here to discuss about the preparation strategy for GATE and ESE for mechanical and production and industrial engineering aspirants, especially from this subject production technology. So here, first of all, myself, Madhushekar, faculty at ACE Engineering Academy from last 8 years. And I have some 10 years of teaching experience, and I did my MECH from IIT Roorkee with industrial engineering, right? So here, if we talk about the weightage analysis for production technology, okay? If we talk about weightage analysis for production technology, here in this table, I gave the weightage analysis for all the subjects, okay? Weightage analysis for all the subjects. Here, production technology is the highest weightage subject, okay, in 2023. It includes material science also, okay, na? In this production technology, material science also included. So it is one of the highest weightage subject. In 2023, 1 mark questions 3 they asked and 2 mark questions 8 they asked. In 2022, set 1 and set 2, if we take 1 mark questions 3 and 2 mark questions 4, and in 2022 set 2, 1 mark questions 5 and 1 mark questions 2 mark questions 5. So what I am saying from this, for GATE point of view, it has very good weightage, and ESE point of view also, especially from this production, there is a good weightage is there, okay, like some 20-30 questions they will ask you for ESE exam. From the material science itself, they'll ask you some 15-20 questions, 15 questions. And again from the production, some 15 questions like that, 20-30 questions they will ask you for ESE exam, especially from this production subject. Okay, now, so in production technology, okay, in production technology, what are the topics here? Material science, welding, casting, metal forming, sheet metal operation, and metal cutting, machining, advanced machining methods, traditional machining methods, and metrology, non-traditional machining methods and metrology. Okay, na? So ikkada meeku because of less time, 1 hour duration, I am going to discuss about 2 important topics, preparation strategy for 2 important topics. They are metal forming and sheet metal operation. From these 2 I am going to explain, because this is completely a numerical based topics, okay. They'll ask you questions, only the numericals, 2 mark questions they will ask you. That's why most of you people are confused about these formulas. That's why I'm here to discuss about the preparation strategy for metal forming and sheet metal operation, right. So in metal forming operation, okay, in metal forming operation, there are 5 topics: rolling, wire drawing, tube drawing, extrusion, and forging. These are the 5 topics. In metal forming operation, the rolling is the most weightage topic. If you go through the previous year IES and GATE questions, many number of questions they asked from the rolling. Okay, many number of questions they asked from the rolling. They are numerical based questions, and till now in GATE exam there is no question from the tube drawing. So you no need to focus much about this tube drawing, but you should focus much about the wire drawing, extrusion, forging, and wire drawing, right? Rolling, wire drawing, extrusion, and forging you should focus. If you remember the formulas, the questions in GATE and ESE exam, in ESE sometimes numerical, sometimes theoretical type questions they will ask you, like methods of reducing rolling force, types of extrusion methods, okay, and forging operations, secondary forging operations. వీటి నుంచి మీకు కొన్ని థియరిటికల్ టైప్ క్వశ్చన్స్ అడిగే ఛాన్స్ ఉంది. బట్ గేట్ పాయింట్ ఆఫ్ వ్యూ తీసుకుంటే కంప్లీట్గా న్యూమరికల్సే. న్యూమరికల్స్ కూడా మీరు ఫార్ములా, ఇఫ్ యూ రిమెంబర్ ద ఫార్ములా, then only you will get to know that. Otherwise It's very difficult to solve those type of questions. They will give you the data in the question paper and you should substitute the data and you should solve by using the given calculator. Right, that's why most of you people felt a difficulty in this metal forming, especially the formulas. Okay, especially the formulas, most of you people will felt difficulty, right? Okay, now first of all, we'll discuss about the first topic. Okay, in sheet metal operations, there are three important topics in sheet metal operations: punching and blanking, deep drawing and bending. Out of these three, if you focus more on punching and blanking, from the punching and blanking, many number of questions they asked in the previous years. Then next is deep drawing, and the least priority I will give you for bending. Okay, now punching and blanking topic is very, very important. Right. So metal forming, 5 topics. Out of 5 topics, you just go to the 4 topics, and sheet metal operations, 3 topics are there. So in case before going to the exam, if you want to revision the formulas, at least if you don't have sufficient time, at least go to the rolling and punching and blanking operation. Okay, these 2 operations are very, very important for your GATE and ESE exam. Right. So first of all, rolling operation. So in a rolling operation, what we are doing, we are reducing the cross-sectional area, we are reducing the thickness of the sheet material. So this is the initial thickness of the sheet material, H0. This is the final thickness of the sheet material, H1. Right. And here because of the time constraint, I'll give you some important formulas and how to solve the numericals by using those formulas. What type of questions they will ask you from these, I'll explain. Okay, now, so theoretical concepts I may not explain here. How this rolling operation is performed, what is the mechanism, all these things I can't explain here, right? So that's why I'll give you important things, the preparation strategy I'm giving here, right? So important formulas, those formulas, if you go through those formulas, that is more than enough, okay, for your GATE exam. Right, now see here, listen carefully. The basic important formula, if I consider, in the rolling operation, volumetric change is equal to 0. Okay, volumetric change is equal to 0. Okay, na? There is no change in volume. H0, this is the width, W0 I am taking. Okay, this is the length, L0 I am taking. L0, H0, W0, H1, L1, H1, L1 and W1. Okay, H1, L1, W1. So volumetric change, if we consider H0, L0, W0 is equal to H1, W1, L1. This formula is important for exam. Sometimes in the question paper, they will give you width is a constant. Width of a strip is constant. If they are given the width of the strip is constant, W0 is equal to W1, then H0, L0 is equal to H1, L1. So either this formula or this formula you should remember. Another formula, here it is, listen carefully. The velocity of the strip before entering into the deformation zone, I am assuming that velocity is V0. Before entering into the deformation zone, the velocity is V0. And after the deformation zone, velocity is V1. So in the deformation zone, we can consider there is a constant volume flow rate of the material. Okay, volume flow rate of the material is constant. So good. Remember, volume flow rate of the material is constant. Volume flow rate is constant. So volume flow rate is constant, right? So from this, listen carefully. Here, H0, W0, V0 is equal to H1, W1, V1. So V0 is the initial velocity, V1 is the final velocity, H0 is the initial thickness, H1 is the final thickness, and as usual width, right? So These two formulas are very, very important for your GATE exam and ESE exam. 2 more questions, numericals, they'll ask you from these two first. Okay, na? That is one. Next, another important thing here it is the bite angle. Sometimes they'll ask you questions from the bite angle. So this is the center of the roller if I consider. This is the center of the roller if I consider. This is the bite angle. I'm considering alpha. So directly I'm giving the formula here. Otherwise it takes time to derive that. That's why directly I'm giving the formulas here. So remember the bite angle tan alpha is equal to root of delta h by r. Root of delta h by r. Okay. Tan alpha is equal to root of delta h by r. And this is the alpha is a bite angle. By using this formula, we should find the bite angle, angle of bite. Remember, angle of bite or bite angle. Alpha is angle of bite. Angle of bite or bite angle. Then the next another formula is length of the deformation zone. Okay, length of deformation zone. Length of deformation zone I am writing L, that is equal to under root. Okay, L is equal to under root R into delta H. This is the formula. By using this, we should find the length of the deformation zone. See here, this is the length of the deformation zone. That is the length of the deformation zone. And one more important thing, to perform a successful rolling operation, there must be some sufficient friction is required. So if friction is less or friction is not there, sufficient friction is not there, then the plate will not enter into the rolls. The plate will strip out from the rolls. The plate will strip out from the rolls, so we may not get the required rolling operation, right? So there must be some sufficient friction is required to perform the rolling operation. So that friction, sufficient friction here it is. So what is the condition to perform a successful rolling operation? That is very, very important for exam. Remember, condition to perform a successful rolling operation, condition to perform a successful rolling is, okay, the friction angle, remember mu must be greater than or equal to, okay, mu must be greater than or equal to tan alpha. Remember, this is the condition. Mu must be greater than or equal to tan alpha. Otherwise, tan beta, beta is a friction angle, okay, tan beta, the tan beta must be greater than or equal to tan alpha. Remember, to perform a successful rolling operation, the friction angle must be greater than the bite angle. To perform a successful rolling operation, the friction angle must be greater than the bite angle. Otherwise, the rolling operation is not going to be performed. So if the friction angle is equal to bite angle, what is going to happen? If the friction angle is equal to bite angle, see, if the friction angle is equal to bite angle, then there is a maximum possible reduction, right? There is a maximum possible reduction is possible. So if the friction angle is bite angle, you will get maximum possible reduction. So for maximum possible draft, if I consider maximum possible draft, remember that is nothing but reduction in thickness, delta H max per pass, maximum possible reduction, that is delta H max per pass. So that maximum possible reduction, if we consider alpha equal to beta, from this you will get mu square R is equal to delta H maximum per pass. Remember, this is very, very important. Maximum possible draft, delta H max per pass Okay, that is mu square r is equal to root of delta, mu square r is equal to delta H max. This is very, very important formula for your exam. Okay, okay na? This formula is very, very important for your exam. Okay na? They will ask you sometimes friction, they will ask you size of the roller, sometimes they will ask you reduction in thickness, sometimes they will also ask you number of passes. See, minimum number of passes. If there is a maximum possible reduction, then you will get minimum number of passes. Kada? Yes. So, minimum number of passes, if you want to get minimum number of passes, okay, minimum number of passes, n minimum is equal to H naught minus H final by mu square r. This is also very, very important for your exam, right? So, next is very important thing vachesi manaku, very important thing is rolling force or roll separating force. Okay na? Rolling force or roll separating force. See, rolling force or roll separating force. Okay, rolling force or roll separating force. Here, listen, there are different cases are there, but I will give you that one with a single formula, one formula, that is rolling force Fr is equal to 2 by root 3. Rolling force Fr is equal to 2 by root 3 y bar F, average flow stress, into area, that is length of the deformation zone, and width, into 1 plus mu L by 2H average. So, just remember this formula, okay? Just remember this formula. So, they will ask you questions from this formula only. Now, listen, y bar F is average flow stress, okay? Remember, y bar F is average flow stress. Y bar F is average flow stress. In case, okay, in case if a material is rigid and plastic, remember, if a material is rigid and plastic, y bar F is nothing but yield strength of the material. In case if a material is rigid and strain hardened, if in the question paper if it is given the value of K, strain hardening exponent, and a strain hardening coefficient AK and N values if it is given, then y bar F formula is, if it is rigid and strain hardened, if it is rigid and strain hardened, okay, if it is rigid and strain hardened, in the question K and N value is given, y bar F is equal to K epsilon T power N by N plus 1. Okay na? So remember, this is the equation. In the question paper, yield strength is given, friction is not, yield strength is given, K and N is not given. Then use y bar F is sigma y here. In the question paper, K is given, N is given. Then use y bar F is equal to K epsilon T power N by N plus 1. That is, you will get from the power law. Right. And in the question paper, if friction is not given, then assume mu equal to 0. If we substitute mu equal to 0, then rolling force is equal to 2 by root 3 y bar F L into W. Okay, friction is 0. If we substitute 0 here, you will get this term 0. So this is the formula. In the question, sometimes they will give you, like this. There is a minimum sufficient friction is required to perform the rolling operation. Minimum sufficient friction is required to perform the rolling operation, they will give. That means that means there is a minimum friction is there, that friction is sufficient to rolling the performance. That means you no need to take this mu value here because there is no friction due to that force is increasing. There is minimum friction is there, okay, to perform the rolling operation. There is no extra friction to increase the rolling force. That's why we should neglect that. In one gate exam, they asked, they asked like this: minimum sufficient friction, minimum sufficient friction is applied or present, sufficient friction is present, like mu equal to 0.1 or 0.08, like that they will give. So we no need to take that this friction because only sufficient friction is there. So rolling force Fr is equal to 2 by root 3 y bar F L into W directly we can take. Okay na? See, we should consider 2 by root 3 because the rolling operation is a plane strain condition based on the maximum distortion energy theory or von Mises theory. We are considering that value. So these are the formulas and important concepts related to the rolling operation. Next is wide drawing operation. Okay na? In case of wide drawing operation, remember, wide drawing operation actually for what purpose? To reduce the cross-sectional area of wire. This is the initial area, this is the final area, this is A0 and A1. This is the initial length of the wire, okay, initial length L0, okay, and the final length L1, okay, initial length L0, final length L1. So volumetric change here also 0. So volumetric change is 0. So we can write it as A0 L0 is equal to A1 L1. And also true strain we can write it as ln A0 by A1, right? These are the formulas. And in wide drawing operation, they will ask you questions related to wide drawing stress and wide drawing force, okay? Wide drawing stress and wide drawing force. The drawing stress is applied to the exit wire. Remember, the drawing stress is applied to the exit wire. So ideal wide drawing force and stress, if we consider ideal wire drawing, if we consider drawing stress is equal to, remember, drawing stress is equal to flow stress into average flow stress into ln A0 by A1. Idi. Otherwise, in the question paper, if it is given yield stress, then sigma y ln A0 by A1. This is the formula. Okay, this is actually for resident strain-hardened material. Here y bar F is equal to K epsilon T power n by n plus 1. In the question paper, if it is given value of K and n, then y bar F is nothing but K epsilon T power n by n plus 1. Right. Now, drawing force, if we consider, wire drawing force, if we consider drawing stress into final area, that is y bar F into AF into ln A0 by A1. Otherwise, sigma y into final area AF ln A0 by A1. That's it. Simple questions. Simple questions they will ask you, okay, for your exam. From these formulas, direct substituting in the formula. And actual wire drawing operation, if I consider actual wire drawing operation, if I consider, drawing force is equal to y bar f into 1 plus b by b into 1 minus a1 by a naught whole power b. Here b is equal to mu cot alpha. Alpha is a semi-diangle, mu is a friction, alpha is a semi-diangle of diangle. Okay, now listen, if you go through the previous questions, not previous year gate questions, they are not asking, they are asking the numericals related to this, but in the question paper itself they are giving the formulas, because these formulas are developed from the slab analysis. So for graduate level, the slab analysis is not there. That's why they are giving in the question only. They are giving in the question only. I'll discuss in the next, I think 4 days back, there is a important questions with analysis. We'll discuss that, these questions, okay na? So definitely in the questions, they will give you the formula. In case for materials, mechanical point of view, mechanical gate point of view, rarely they'll ask you, but production, mostly sometimes they'll ask you. So it's your choice. If you want, you can remember, otherwise not required. So drawing force is equal to drawing stress into final area, right? Drawing stress is this, y bar f into AF into 1 plus b by b into 1 minus a1 by a naught whole power b. These are the formulas, and if we want to calculate y drawing power, so y drawing power, if you want to calculate drawing force into velocity of exit wire, velocity of exit wire. So by using this, we can also calculate power. Right. So this is one important thing for your exam. Next, another important thing from the y drawing operation is maximum possible reduction in cross-sectional area. See, they will ask you questions, theoretical type question for a gate and IS. Maximum possible reduction in cross-sectional area, maximum possible reduction in cross-sectional area. Ideal wire drawing I am considering, ideal only they will ask you, ideal wire drawing. Within the ideal wire drawing, two cases are there. You are familiar. What are those two cases? First one is material is rigid and plastic. First one is material, wire material is rigid and plastic. If we consider rigid and plastic, R is equal to, okay, our percentage of reduction in cross-sectional area is equal to 63.2. Okay, 63.2 percentage. You just remember that value. That's it. Okay. Second is rigid and strain hardened material. Rigid and strain hardened material. For rigid and strain hardened material, percentage reduction is equal to 1 minus e power minus n plus 1 into 100. If you substitute n equal to 1, you will get this value. For rigid and plastic material, n equal to 1. Strain hardening exponent is 1. For rigid and strain hardened material, this is the formula. These two are also very, very important for your exam. Gate and IS exam point of view, sometimes direct questions they will ask you. 63.2 is the answer. How they will ask, maximum possible reduction in cross-sectional area in case of ideal wide drawing for rigid and plastic material, that is 63.2. For rigid and strain hardened material, that is 1 minus e power minus n plus 1 into 100. So these things are very, very important from the wide drawing. So wide drawing we discussed. Next, if we talk about the extrusion process, same. In extrusion process also, same, volumetric change is 0. Okay, volumetric change is 0. From this, sometimes they'll ask you volumetric change is 0. Okay, volumetric change is 0. That means initial volume, that is A0 L0 is equal to A1 L1, and here force is applied to the initial block by using a ram. Okay, force is applied to the initial block. Okay, so that we call it as extrusion force. Okay, now, and remember extrusion ratio, another formula, extrusion ratio, that is I am representing with R is equal to A naught by A1, extrusion ratio A naught by A1. So true strain, that is epsilon T is equal to ln R. Right. So from the extrusion also there is a chance to ask a question, only numericals. Okay, and listen carefully, the numericals are also very easy questions they will ask you. Okay, we will discuss those formulas, and you just go through those formulas, that is more than enough. Okay, right. Now if we consider ideal extrusion, in case of ideal extrusion process, ram pressure, remember ram pressure I am representing, ram pressure is equal to y bar f ln A naught by A1. These formulas are same as a Y drawing. Only the thing is different, extrusion force is equal to y bar f, initial area I am taking. Previously A1, Y drawing, but in extrusion I am taking A naught because I am applying the force to the initial billet material. Right. So A naught ln A naught by A1. Otherwise, if a material is a resident plastic material, sigma y ln A naught by A1. Otherwise, for force if we consider, okay, sigma y A naught ln A naught by A1. These are the important formulas. So by using these formulas we should find the ram pressure and extrusion force. And if we want to calculate the power, power is equal to extrusion force into velocity of ram. Right. This is ideal extrusion process. Okay, na? This is an ideal extrusion process. Sometimes in the question paper, actual extrusion process, indirect extrusion process, indirect or actual extrusion, direct extrusion process, if we take backward and forward, there must be a friction present, okay, between the die and workpiece, and also there is a container wall friction. So in such case, we should use Johnson equation of strain. Remember, for direct extrusion, okay, and direct extrusion, and in the question paper, okay, Johnson equation, Johnson strain constants, true strain constants, Johnson true strain constants A comma B given in the question paper, Johnson true strain constants A comma B given, but don't worry, in the question paper formula also they will give, you no need to worry. So remember, Johnson true strain is equal to A plus B ln R. R is equal to A naught by A1. So from this, listen carefully, ram pressure is equal to y bar f into Johnson true strain, that is y bar f into A plus B ln R. This is the formula. If a material is resident plastic, sigma y we should use here. If a material is resident strain or n, y bar f is equal to k into epsilon t power n by n plus 1. Here, listen carefully, sometimes A is equal to 0.72, 0.9, they will give you, B is equal to 1.2 to 1.5, but you don't need to remember these values, in the question paper they will give. So remember this equation, and extrusion force if we want to calculate, same into area, initial area, y bar f A naught into A plus B ln R. This is the formula. This is the formula of extrusion force. So just remember these equations and these equations. These equations for ideal extrusion, very simple, stress into strain. These equations for axial extrusion. And one more formula, one more important thing I'll give for extrusion, that is hot extrusion. Okay, hot extrusion I'll give you. Hot extrusion. So hot extrusion, in the question some extrusion constant they will give you. Hot extrusion constant, K is hot extrusion constant. Hot extrusion constant they will give. So if in the question hot extrusion constant is given, okay, ram pressure is equal to K ln A naught by A1. That's it, simple. And extrusion, ram pressure this is, and extrusion force if they asked, K into A naught ln A naught by A1. These are the formulas. So ram pressure is equal to K into ln A naught by A1, and extrusion force is equal to K A naught ln A naught by A1. So these are the formulas. By using this, see, they will not ask you beyond this. I am giving all the things here. You just note it down, these things in a small pocket notebook and revision it. I will give you guarantee that there must be a question from this. I'll give you a guarantee that there must be a question from this. Okay, na? So be careful. Right, this is extrusion. And next is forging. So from the forging operation, listen carefully. In the forging operation, this is the initial block. This is the initial block before forging operation. This initial block having a diameter D naught and a height H naught. Okay, diameter D naught and height H naught. Now by using forging operation, compressive stress, I am getting the final diameter DF and the final height HF. So here also we can say there is volumetric change, that is 0. Okay, volumetric change is 0, right? So volumetric change is 0. So we can write cylindrical body, if we consider pi by 4 d naught square h naught is equal to 5 by 4 t1 square h1. So d naught square h naught is equal to d1 square h1. This is very, very important. This is very, very important for exam. Okay, na? Volumetric change is 0. Volumetric change is 0. So in your exam paper, they will ask you the extrusion force and energy, especially for cylindrical plate or a cylindrical body. Remember, for a cylindrical body, okay, extrusion force, forging force is equal to, remember, very, very important thing, we are not using average flow stress here. We are using a flow stress because we are calculating the forging force at the end of the forging operation, maximum forging force. So YF into AF final area into 1 plus 2 mu RF by 3HF. This is the only one formula. You just remember this is the only one formula. In case in the question paper K and N value is not given, remember YF, I am not using Y bar F because I am calculating the forcing force at the end of the stroke, right? So I am not calculating Y bar F. That is very, very important. Okay, Y bar F is average flow stress. This is just a flow stress. Okay, this is just a flow stress. So YF is equal to K epsilon T power N. And in case in the question paper, if it is given in the question paper, if it is given yield stress, that is sigma Y AF into 1 plus 2 mu RF by 3HF. Just follow this. And in the question paper, if friction is not given, if a substitute mu equal to 0, you will get the answer YF into AF or sigma Y into AF. So that's why, remember, you just remember this equation. In forcing, complete forcing operation, this is the only one equation. If you remember that equation, that is more than enough. They'll ask you only for cylindrical body. Even if you go to the previous year questions, mostly they asked only cylindrical body. So remember, they'll ask you from this formula only in the forcing operation. Right. So these are the formulas related to forcing operation, important things related to forcing operation. Right. In a punching and blanking operation, especially sheet metal operation, what are the important things, you know? The important things in this punching and blanking operation is design of punch and die in punching and design of punch and die in blanking. Okay, na? Design of punch and die in punching and design of punch and die in blanking. And remember, clearance in the question paper they will give you. Mostly clearance they will give you. Otherwise, if it is not given clearance, CR, radial clearance, is equal to 3/2T root of u. It depends on the thickness and ultimate shear strength. In case diametrical clearance, if I want optimal clearance, this is 0.0064 T into root of u. Right. Now, design of punch and die in punching operation. Design of punch and die in punching. Design of punch and die in punching operation. So remember, in punching operation, clearance is provided on a die, right? So remember, punch size is equal to hole size and die size is equal to, okay, punch size or hole size plus, okay, 2 into radial clearance or diametrical clearance, and clearance is provided on die. Clearance is provided on die in case of punching operation. Okay, na? Clearance is provided on die in case of punching operation. These are the formulas. They are very, very important for exam. Next one is design of punch and die in blanking operation. Okay, design of punch and die. Remember, design of punch and die. Design of punch and die in blanking operation. Okay, design of punch and die in blanking operation. In blanking operation, remember, the clearance is provided on punch. So blank size, see, die size is equal to blank size. Okay, punch size must be less than the die size, so that punch size is equal to die size minus 2 into radial clearance. Okay, die size is equal to blank size and punch size is equal to die size minus 2 into radial clearance, and clearance is provided on punch. In this case, clearance is provided on punch. In this case, clearance is provided on punch. So design of punch and die in punching, clearance is provided on die. Here clearance is provided on punch. So punch size is equal to hole size here, die size equal to blank size here. So for mechanical engineers, mostly they will ask you questions from these two only. And there is one more, maximum punch force also they will ask you. So these two are very, very, very important for exam. And maximum punch force F max is equal to, okay, perimeter into thickness. Remember, perimeter, why I am writing perimeter? Because sometimes in the question paper they may not use only circular, sometimes rectangle, sometimes square, sometimes different shape. That's why I am writing perimeter into thickness into ultimate shear strength. Perimeter into thickness into ultimate shear strength. Suppose if it is a circular blank or a circular punch operation, if you want to make F max, that is perimeter for circle, that is pi dt into tau u. In case if it is a square, okay, if you want to make a square blanks or square holes, F max is equal to 4 into A is the side of a square, 4A into T into tau u. Like that. If it is a rectangle, okay, if it is a rectangle, remember F max that is equal to 2 into A plus B into T into tau u. So like this, different shapes, sometimes circle they will give, sometimes a square they will give, sometimes a rectangle they will give, a different shape they will give. That's why I am writing here maximum punch force is nothing but perimeter into thickness into ultimate shear strength. Perimeter into thickness into ultimate shear strength. Right. And also one more important thing, listen carefully, one more important thing they will ask you, that is providing maximum shear. Providing shear, there is one important formula, especially for production people, they will ask you, providing shear on a punch or a die, what is the force? Providing shear is a certain reduction in like a grinding operation. Let us say this is a shear is a length dimension, okay, like grinding bottom portion of a punch, so that we can reduce the punch force, right? By providing shear, work done is same, but force is going to be reduced. So F max into penetration thickness PT by, okay, PT plus S. This is the formula, right? So two formulas you should remember. This is the one formula to calculate the maximum punch force. Fs is equal to F max into PT by PT plus S by providing shear. And this is another formula without providing shear. So these questions they will ask you from punching and blanking. See, remember, very simple, design of punch and die, punching and blanking, next calculation of punch force, next providing shear. These questions they will ask you for your exam point of view. Okay now? Now, next in deep drawing operation, what type of questions, basic questions, initial blank size. See, deep drawing operation is used to make cup-shaped components. Okay now? So cup-shaped components, if I want to make a cup-shaped components, what is the initial blank size required? Cup-shaped components, if I want to make a cup like this, what is the initial blank size required? So that if I want to calculate, let us say this is the initial blank. This is the initial blank. The blank size is this. Diameter blank is circular in shape. So from this I want to make a cup like this. I want to make a cup like this. This is the cup diameter and this is the cup height. Right. So they will ask you question, straightforward question. If I want to make a cup of diameter so and so, height is so and so, what is the initial blank size required? If you want to calculate that, you should equate the surface area. One side surface area of blank, okay? One side surface area of blank is equal to outside surface area of cup. You just follow this one. Remember, one side surface area of blank is equal to, okay, outside surface area of cup. Outside surface area of cup. Outside surface area of cup. So pi by 4 blank diameter pi by 4 dB square is equal to pi by 4 d square bottom portion, pi by 4 d square plus pi dh. From this, dB is equal to under root d square plus 4dh. This is the formula, very, very important for exam. Straightforward questions they will ask you. So they will give in the question paper cup diameter and height, depth, deep of a cup, diameter of a cup. They will ask you what is the initial blank size. easy to calculate from this. And also, deep drawing operation is not performed in single stage. The deep drawing operation is performed in multiple stages. This is a blank. First draw, second draw, third draw. So different cups. For example, I want to make a cup like this. I can't make at a time from this blank. So this is the blank diameter, dB. This is the D1, initial, first draw. This is the second draw, D2. This is the third draw, D3. So why I'm explaining this is, they will ask you the number of draws. Calculate the number of draws, they will ask you. That's why I'm explaining here. See, remember the number of draws we can measure with two methods. One is, okay, draw reduction ratio method. Draw reduction ratio method. In case of draw reduction ratio, diameter of blank minus D1 by diameter of blank. Okay, DRR1 in the first draw, and DRR2 or DRR1 and 2 are same, then D1 minus D2 by D1. Then second one is limited draw ratio. Limited draw ratio. Second one is limited draw ratio, LDR1, that is initial diameter by first, then LDR2, that is D1 by D2. Like that, we should calculate the number of draws, first draw, second draw, like that. Okay, na? First draw, second draw. So in the deep drawing operation, we are calculating number of draws with these methods, draw reduction ratio method and limited draw ratio method, right? And deep drawing force. So deep drawing force, if I want to calculate, remember pi d1, first draw if I consider, pi dt sigma ut into, okay, dB by d1 minus c, that is 0.7. By using this formula, you can calculate, right? By using this formula, you can calculate drawing force, right? This is the information about drawing. And the last one is bending. So from the bending, they will ask you bend allowance questions. Remember, bend allowance questions. Bend allowance is this one. Remember, this is the bend allowance. So how much initial length of the sheet is required to make like this bending? So that bend allowance is equal to R plus K into T into alpha, that is a bend angle, into pi by 180. Okay, this is the bend angle. Remember, this is the bend angle alpha. Okay, na? This is included angle. Okay, this is included angle 180 minus alpha. So be careful, because I'm applying force from this end. So bend angle alpha in terms of degrees, that's why I'm converting into radians. R is the internal radius of bend. K is a thickness, T is a thickness, K is a stretch factor. So these are the formulas and important concepts for your GATE and ESE exam. They will ask you. So you just go through these formulas. That is more than enough to get the questions, to solve the questions for GATE and ESE from this metal forming and sheet metal operations. And next in 25th, I think so, I'll discuss important questions with analysis. How to solve these questions with these formulas, all these things I'll explain. All the best for you.